Precision is a multifaceted venture. Precision in woodworking is much different than precision in manufacturing. Close enough is not good enough. This video shows machinist precision, which is 1/1000th of an inch or smaller. That's so small you can't see it with the naked eye. The average piece of paper is around 4/1000th of an inch thick. At the end of this video, a computer measuring machine will inspect a part going out to 1/10 of 1/1000th of an inch. Our machines are so precise that we could cut a thickness of a piece of paper into 40 slices, that is 0.0001 of an inch. I now turn it over to Tom, one of our instructors here at STCC Mechanical Engineering Technology.
So here's the part, and I'm going to inspect this with 3 different gauges from least precise to most precise. So the first is a ruler, and this ruler is divided into hundredths. So if you take 1 inch and you cut it into 100 pieces, that's what this is measuring. And here on this first step, I see that it is about 1 inch. Next step, I see it's in the ballpark of maybe 0.85, maybe 0.9, hard to tell. Let's call that 0.9. Next step is around 0.75 or so. The next one is 0.65. Again, very hard to tell. And it looks like maybe this is all one piece here. All right, so I've written all those values down over here. Next, I'm going to measure with the next most precise gauge. This is called dial calipers. So I'll start again with the highest step here. And when I measure that, I get 1 inch exactly. Move to the next step, measure that, I get 0.881. Next step, measure that, I get 0.757. Next one, 0.631. Next one, 0.626. Next one, 0.625. And the next one, 0.623. Okay, so again, I've written all those down on this piece of paper over here, and I'll come back and measure all the same things with the next most precise gauge, which is called a height gauge. So for the height gauge, I'll come down and find this piece of granite. This is called a surface plate. And you can see this little dial here reads 0 when I get to the surface plate. And then I'll zero out the readout over here. We'll come up and take a measurement. And really, this is doing the exact same thing that I just did with the other 2 gauges. So there, I'm getting 1 inch 1/1000th. Move to the next step. I'm getting 881 thousandths and 5/10. That's 0.8815. Here I'm getting 0.7575. So 757 thousandths, 5/10. Next step, 631 thousandths and 5/10. That's 0.6315. Next step, 0.6265. That's 626 thousandths, 5/10. Next step, 0.6250. That's 625 thousandths. And the last step is 0.6240. So again, I've taken the liberty of writing down all of those numbers on this piece of paper here. And speaking of this piece of paper, let's measure the thickness of this paper. With a ruler, when you measure it, I have no idea how thick that is. When I measure it with dial calipers, I see that it is around 0.004. That's 4/1000ths of an inch. And then when I measure it again with the linear height gauge, put that right to 0, and we'll take the reading directly off the dial. You can actually see the dial jumps all the way to maybe 3.5, maybe 4/1000ths. Let's call it 4/1000ths. So really, the calipers and the height gauge told me something very similar, which is good. You hope you get the same answer with each. Next, we're going to move over to the CMM and see what it has to say about these sizes. So here I'm going to fixture up this part on a fixture plate on the Zeiss CMM, and then we'll execute a program that has already been written to inspect this part in exactly the same way that we inspected it with a ruler and calipers. Alright, so right now the CMM is going to find the part. I can see that it's touching the fixture plate first to find where the bottom is. That's replicating the same thing that we did by putting the part down on that pink stone. That pink stone is called the surface plate. So right now it's finding the front of the part. That way it knows where the part is back and forth this way. Right now it's finding the left side of the part, so that way it knows where the part is this way. Right now it's probing on the depths, the same way that I did with the linear height gauge. I notice that it's taking 7 independent steps. Right, so it's recording all of these values behind the scenes, and it's recording them to a level of precision that is far, far greater than what the ruler, calipers, or height gauge are capable of. Right here, it's actually doing a scan path, so it's putting the probe down and leaving it down on the part, and taking thousands of points for every inch. So that's all done. We can look over on the computer screen over here, and reading the report, I see that the first step is 1 inch, 0 thousandths of an inch, and 9/10ths of a thousandth of an inch. So this is hard to really wrap your mind around. We measured the thickness of a piece of paper, and it was 0.004, or 4 thousandths of an inch. If you take an inch and cut it into 1,000 pieces, 4 of them is the thickness of the piece of paper. Now when the CMM measured this thickness right here, from the top to the bottom, it found that it is exactly 1 inch. It's 0 thousandths of an inch, and 9/10ths of 1,000th of an inch. So it's going out to 4 decimal places. That is extremely, extremely precise. All right. One recurring theme that I'm noticing on my piece of paper with all of my measurement values written down is that the ruler, I could really only tell 2 decimal places worth of precision. With the caliper, I could kind of sort of tell 3 decimal places, but I wasn't that confident. With the height gauge, I was very confident, and I could go out to 3 decimal places. And with the CMM, I can easily go out to 4 decimal places, and really, I could even go out to 5 decimal places if I had to. Now, another very cool thing about the CMM is it captured all of that data automatically in the dimension report, whereas when I measured with the hand gauges and the height gauge, I still had to write down my numbers on a piece of paper. Now, going one step further, I can also open up the program that drove the CMM, and you can see that there's this interesting stepping pattern here. So I think this is actually that scan path that we ran over these 4 steps here. And where you see the spiking is every time we cut just a little bit deeper on the part here, you can see that the probe actually picked that up. Now, if you recall from when I measured this with the caliper, the first step right here was 631 thousandths. The second one was 626. The third was 624. And the fourth was 623. So even on the last 2 steps, 624 and 623, that's only 1,000th of an inch apart. That's a quarter of the thickness of a piece of paper. And the CMM is able to see that as clear as day. Now, also, on the last step here, I didn't even take any measurements of this with hand gauges. But you can see the way that it was machined on our mill, there are many independent passes, and if you run your fingernail over the top, you can actually feel that it's not the smoothest surface, but it's pretty smooth. Now, when I open up the scan path of that last surface, it's amazing to see that the CMM actually saw every single individual cut that the end mill used as this was machined out. So, some extreme precision coming out of this CMM. This CMM could actually inspect a hair even if you cut a hair into 40 different pieces. That's 1/10 of 1,000th of an inch. is about 1/40th the thickness of a human hair. And this graph that we're seeing right here tells that story visually. So some very, very cool technology that we have access to. We're also very grateful to say that we just got a grant and we're building out a new classroom that has 5 of these CMMs, and we're happy to teach students how to use them. So thank you for watching, and I will see you at the next video.